Sorry about that. All right. We're okay? All right. We got squad. Okay. We're going to get started in just a second here. I know we just opened the doors. Everyone's kind of still running around. But I want to make sure that this gets kicked off and stays on track today. All right. I just realized that. All right. That looks like a good quorum. Let's get started. Welcome to VMware Explorer 2024 Las Vegas. My name's Mike McLaughlin. You're in the community theater. This is a quick talk, so we're going to be done in about 10 minutes, actually about 20. But today we're going to kick off the session with a conversation about disasters, actually disaster recovery, all right? And I know this is probably important to most of you because you run your company's businesses and you don't want to get taken down with some sort of disaster, whether it be a site disaster or a cyber attack. So we're going to talk a little bit about that in the context of business critical applications and basically VCF workloads. So with that, let's jump in. We'll give you about 10 seconds to read our disclaimer slide. I believe this is being broadcast, so. Okay, good. Serious stuff, but I'm not going to read it to you. Two things I want to talk about today, this morning, all right, is the difference between site and cyber disasters. We've been dealing with this for years, and this is a topic that's near and dear to me. I'll be talking about it all week, but there are two different kinds of things here, and they affect your organizations and your planning and preparation differently, all right? And given that, we're going to split that apart, and then we're going to look at the aspect of protecting your sites and recovering your sites in the event of either of these. So let's jump in. I'm assuming you're here because you've virtualized many of your applications. What we want to do is establish now a foundation for those, not only when they're running in production, but when something happens and we need to recover those. Basic terminology you're probably familiar with, but I like to use this because this will be some of the decision criteria that you'll need to apply when picking the right solution, when applying the right techniques, when dealing with continuity in your business. Is recovery points are to the left and recovery time is to the right. Recovery points is how far back do I have to go to get back into service, and to the right is how fast can that happen. And this will make a difference when you're looking at business continuity, DR failover, and ransomware recovery, because those endpoints will be constantly shifting. And you'll want to have these conversations within yourself, your team, your business partners, the application owners, is what are we designing for? What can we pay for? Because that's also very critical. These are business economic decisions. Now, with the VMware products, VMware Live Recovery, introduced earlier this year, hopefully everyone's gotten through the general confusion of renaming a product in the midst of its life, all right? But it is essentially the umbrella for dealing with disasters, all right? And there are these two kinds, disaster recovery and ransomware recovery, or a site disaster and a cyber attack. They are different. I'm going to start to separate these two problems a little bit right now as we move forward. With a disaster recovery solution, you typically have one site and something happens that site's no longer available, whether it's a man-made problem like a power situation or Mother Nature striking. But what you want to basically do is fail your business operations over to another site and get back up and running as quickly as possible. That's a whole different problem than if you have an internal cyber attack. Typically the site is still intact, but the contents now have been compromised. You don't just pick up because you've been malware attacked and run to another city and start running, because you're probably going to take all of that with you. What you want to do is fix that problem in place, if possible. You've got your data center. Hopefully they haven't turned off the power or crushed the building or fired all the employees or whatever. You still have your infrastructure, but the things inside are now impacted, and they're two different problems. So let's peel this back a little bit further. If you look at these two types of recovery and you think about your applications, Having a secondary site is really critical if you need to be back up and running relatively quickly and can't build that second site, and you want your business to basically shift across town, across state, across countries, whatever, and resume operations. You're going to treat the planning and preparation and all of the testing differently for that type of disaster avoidance and disaster recovery. You're going to have possibly similar sites on both sides, all right? And you're going to be failing back and forth in testing because you want to resume operations as quickly as possible. In the event of a cyber attack, your application, something inside your organization is compromised. And I like to use the hospital analogy here, if you don't mind for just a moment, is your applications have gotten very sick and you want to heal them, you want to repair them, remediate them, validate, verify them, use whatever term you want. You're typically going to want to take them out of their operational environment, inspect them, validate them, clean them up, get them ready to go back to work, and put them back in a safe environment. All right, so it's a little bit different problem for planning, preparation, testing, and even the final operations. And this is, you can look at the details behind it. There's a little blog connection on TechZone there. If you want to follow that later, that's great. But this is essentially one of the key problems of dealing with any kind of disaster that strikes your infrastructure. So VMware Live Recovery has taken the two core existing products. Site Recovery Manager, if you've been around longer than 7 months with VMware, you'll know that that was a product. Yeah, Site Recovery Manager has been around for years, and so was VMware Cloud Disaster Recovery, two key technologies used for solving slightly different problems. All right, we brought those together under one umbrella. Now, they aren't a single product yet. You'll see that, but everybody take a note. Listen to the announcements this week. Pay attention to everything that I can't tell you today, because tomorrow is the opening keynote. All right, but what we're doing is bringing those together under a common centralized infrastructure so that you can manage and administer protected virtual machines as the core thing. So now what we're saying is protect your virtual machines, either for site or cyber recovery. All right, and the dashboard here lets you kind of work through the setup, the management of your licenses, the management of multiple sites. Most organizations we're dealing with today do not run a single vCenter. They are running multiple sites, multiple installations, multiple workload domains, and we need to be able to find continuity and understand how those look in the landscape of recovery and leverage, all right? And we're going to do that essentially through a unified dashboard, a centralized management point to manage these two technologies as they begin to move closer and closer to a single solution. All right, so these are the two solutions. I'm going to touch on these briefly in the next couple of minutes. If you're familiar with them, this should be a little bit of a review. If not, what I want you to see, though, is the similarity of the structure of these two products, but then we're going to split them apart in how they're used. So they basically all start in a vCenter environment. That's where your VMs live. They're living on some storage, they're running on some vSphere, and they're managed in a vCenter. The virtual machines, your applications run on top of that. We basically want to help you get the infrastructure solid so that we can build that up. And if we see here a protected and recovery site, we're going to basically put in, this one is VMware Live Site Recovery. We layer that in. We're going to layer in the replication here. Now, there are multiple ways of moving the data from A to B, and B to A, and A to B, and B to A. All right, we're going to use vSphere replication for our example today. You could do this with array storage base. You'll soon be able to do it with some other technology that you'll hear about later this week, which is really cool. But on top of that, we can plug in and use storage-based replication if you want. But you're basically building your two sites kind of as mirrors of each other. You want to basically be able to go A to B, B to A, maybe cross-directional, but that's going to give you your site disaster recovery capability. Your applications live on top of that, and they run either at one site or the other. In some cases, we have customers running applications that actually span and stretch both sites. That gets really complicated. We can't do that in a quick talk. All right. If we look at the cyber recovery piece, it looks very similar. It builds on your vSphere environment, your storage environment. Notice the right-hand side here, though. This is going to be one distinct difference that you'll see for the next several months. Is remember the hospital analogy. I talked about going and taking the patient and getting the VM healthy. Well, where do you do that in a cyber situation? You need a clean room. You need an isolated recovery environment. You need some place to take that infected virtual machine, that impacted virtual machine, out of the population and work on it. We're going to leverage VMware Cloud on AWS to do that. We're using the cloud-based capability mainly for the recovery, not to run your business, but to run that virtual machine to health. All right, so think of this as the ICU at the hospital. You're not going to work in there. The doctors are going to come in, they're going to isolate you off, but as soon as you're healthy, you get your discharge papers and you go back to work. All right, that's this model here. You're not working in the cloud, you're healing in the cloud. And we're going to do that by basically building an infrastructure that lets me move my workload there and run it so that I can run through the mechanisms. So these are built on similar premises. Production site, recovery site, we're going to connect these together with live recovery mechanisms. All right, we're going to build the notion of protection groups. All right, protection groups are the collection of virtual machines that belong together. All right, nobody runs a single vCenter, nobody runs a single VM. All right, multiple VMs have to be collected together, so when I move an application over, I have all the pieces that I need for it. All right, so protection groups are going to be really important. We need to tie these two sites together because if I'm going to fail over and get right into production, I need to have all my networking and all my resources in place. If I'm going to fail over into an isolated environment, I want to have enough infrastructure there so that I can mimic a real workload, so that I can put that virtual machine on the treadmill, so to speak, and make sure it's healthy. I've never seen a treadmill in the ICU, but it's probably not a bad idea. They usually send you down to level 2 for that. And then ultimately, the recovery plans are the key part here. These are the automated, documented workflows of what goes from A to B and back. All right, and the recovery plans are encoded inside of the VMware Live Recovery solutions. And these are the things that we're going to help you automate through testing and actual use. All right, and so this structure here is built in both of these tools. A little bit differently, we'll talk about that later this week in my tutorial, but the idea is you've got this framework for building a site recovery capability so that your applications can run. All right, so just a little bit of a verbiage for those that don't like pictures. All right, basically protection groups, mappings, recovery plans, and often infrequent testing. Because if you don't test these things and crisis hits, that's a bad time to start testing. All right, and both of these solutions, all of this infrastructure allows you to move that back and forth and get familiar with the processes of failing over and bringing applications online, of failing over and investigating malware attacks. It's okay to fail over a healthy machine and look at it. I go to my doctor regularly. Nothing's wrong with me. Annual checkup. He gives me a full work done. He's like, okay, you're good. Go back. All right, I don't have to get checked in. Those kinds of things are very important in your business operations. All right, let's talk a little bit about the protection groups and a couple pieces here just graphically. I mentioned these are things we want to group together. All right, both of these solutions, this whole infrastructure is built on this, building the protection groups. Now, from your application perspective, whether they're tier 1, tier 2, how they're organized, you're going to need to sit down either with your team or with our professional services, kind of work through this. There are no best practices here that I can just like give you right now and take away. But it really is understand your business and group things that need to be together when you need to work on them. All right, we'll schedule those with the appropriate retention. Remember the RPO? How often do I want to take these backups? How long do I want to keep them? What do I want to do with them? Again, there's a cost for some of this, but we'll figure that out. And just basically schedule that all in so that you have the proper safety net of recovery points when disaster comes. The next thing is those recovery plans. And this is a kind of a graphical notation of what's in a recovery plan. Well, there's typically going to be some kind of scope. What's the recovery plan cover? You can have multiple recovery plans. They can work on multiple things. That's okay. So there's going to be a scope. There's going to be some kind of mapping from A to B in that recovery plan. This VM is going to run here. If I need to fail it over, it's going to run there. This resource, this network, this folder, this basic mapping, all right? There'll be some customizations in these recovery plans because you don't just pluck it out and drop it over there and let it run. Sometimes you have to change the IP address, move some things around, change how it's powered on, maybe instrument it with some tools. Don't know. But there's going to be customizations capable, and then ultimately the steps involved. All right. The sequence of recovery. Do this first, this next, this next. In a site disaster recovery, that's really critical. It's very much like a run book. All right. Site A is down. Site B, here's how it comes up. Step 1, step 2, step 3. All right. If it's a ransomware recovery or a cyber recovery, you might look at the steps a little bit differently. It'll give you some indication of what the critical applications first are, but you're going to have to basically, like, you can't necessarily bring an application back if its predecessor isn't healthy. There's just a number of things. So the steps are critical. And then obviously, if we're tweaking this recovery plan for site or cyber recovery, this will all be encoded in this logical structure that we can then keep online, share with our colleagues, run through regular testing, feel much better should a disaster occur. All right. So we talked about this a little bit. I just want to put this in context of a VCF environment. It's kind of one of the key talks this week. If you think about a VCF environment as being multiple workload domains and virtual machines and hardware and whatnot, if you have a disaster, one is you need another site. Now I've drawn a network isolation in there because in some cases that other site starts off completely isolated. It's not talking to the original site. The original site might be down or it might be infected. But think of this as just another workload domain where I can run my applications. Makes sense to me. I'm going to have snapshots and replication feeding that environment so that I have something to bring back online. Now, in the case of a cyber attack, the last good backup might not be adequate. I might want to have a deeper inventory and maybe some metrics that I'm looking at on those recovery points so that I can basically pick and choose. And the analogy I use is like, how did you feel last Friday? Oh, not so good. How about Thursday? How was Wednesday? Wednesday's a good day to start. Let's take your Wednesday health and fix you to Monday. All right. You want to basically have recovery points to work from. If I just say go over there and work, you take everything and go. It's a little different scenario. So we want that. Now, for a disaster recovery, a site disaster, we've got our run book. We've got step 1, step 2, step 3. We can just open that up and let the tool open that up and start running through it. For a cyber recovery, we want a little bit more of I'll say a science project, all right? Because we're not exactly sure where the impact is, how to get it out, how to get everything tied together. This guided workflow goes through a validation and staging loop for me so that I can bring some sanity to the chaos. Because if I've got 10 or 100 virtual machines and I don't know exactly what state they're in, when they were best healthy, and I've got to iterate through that, I'm going to want some control over that. That guided workflow is going to help with that. At the end of the day, I might also need some additional tools. All right, I might want to put some of the new next-gen antivirus tools in there and really investigate what's going on inside those virtual machines. As I bring those into that environment to inspect them and work them through a recovery process, one of the key things for a cyber recovery is also isolation. We want to be able to cordon off each application so that it can't escape just yet. All right. Starting up a virtual machine, the first thing it might do is try to access an IP address you do not want it to talk to. Or it might sit dormant for a while until the internet gets open. You want that behavioral analysis is critical, and isolating that, again, that needs to be in a bubble, just like in the ICU. All right. So we're working through this. So for a cyber recovery, it is a little bit different. We've got some additional things we have to layer in. This is what we're working on using the VMware Live Cyber Recovery and some future things that you'll hear about later this week. But if you think about a cyber recovery solution for VCF, it probably looks something like this. All right. I'm going to just skip through this a little bit. It's just a different graphical representation of the same thing. But we're basically using VMware Cloud on AWS as that extra workload domain right now because it's easy for us to manage that and all aspects of it, all of the networking and component aspects, even the provisioning of new hardware, so that you can get this isolated recovery environment very quickly and at hand just in time to do the remediation. We're not expecting you to run your business in there. We're expecting you to clean your virtual machines in that isolated recovery environment. Okay. A couple of things that were announced recently. I just want to bring these in because we're talking about protection and recovery. vSAN data protection. For vSAN ESA, some really nice new features. So the online snapshot capabilities that are built into the vSAN architecture can now be leveraged with the cyber recovery solution as well. So we're tying those two products together. There'll be some demonstrations of that in the expo and possibly in some sessions and some conversations about where that's going. But the underlying storage inside of the VCF environment is getting its enhancements further integrated into the layers for protection and recovery. There's whole sessions on just this topic this week. I suggest if this is interesting, go look those up. But I just wanted to bring that in because data protection and recovery are slightly two different things. We're protecting locally, so remember business continuity and HA and things. You might be able to solve the problem locally if it's contained quick enough. If you've got to get off site because the site is down or because the disaster requires remediation through cyber mechanisms, it's going to be a little bit different. We're going to use a different mechanism to get the data there. And then the last thing I want to leave, and we got just a minute to do this. So 3 things. For disaster recovery and cyber recovery, VMware Live Recovery is what it's called now. So if you're ask people about VMware Live Recovery, it is the common family for both of these solutions. Those 2 solutions are site recovery and cyber recovery because they are slightly different problems. And from an architecture and implementation perspective, there's 3 things you got to think about. So one is, at the application level, that's your expertise, or at least the teams you're working with. Make sure you know how to validate the application is operating correctly, what needs to be grouped together, think protection groups and organization and sequence of steps. At the VM level, I would say count on us for the orchestration and the management between the sites. So if you want to get a VM running here or here, the VMware layer below that, the vCenter, vSphere, and vSAN capabilities and storage below that, that's what we're dealing with. And then finally, we're going to tie back to that SLA slide, is there are a lot of ways to get data from A to B, all right? vSphere replication, storage replication, there's even some other third-party mechanisms. Figure out at the data level what you need to meet the business needs for either business continuity, disaster recovery, or cyber recovery, because they will be slightly different, and you might need some other tools that will be application specific. There are presentations on managing SQL Server and Oracle databases and multi-tier web apps. All of those things are very critical. They tie into that top layer. So live recovery, 2 types of use cases, 3 layers of concern for application business continuity in your environment. All right? It's all under VMware Live Recovery. I hope this was helpful. There's a lot of stuff going on this week. Take notes, pay attention, enjoy yourselves. Welcome.
Hello, everyone. We are missing a speaker for the next session, so my sincerest apologies. I don't know where he is. I'll give him 5 more minutes before I'll make another announcement, but you can do what you want. If you want to hang around, of course, you're welcome to hang around. We've tried to tweet at him. I've sent him an email, but no response at this point, so I'm not sure if he's going to be coming or not. So you can make your decisions. We'll give him a few more minutes. So sorry.
It's like college. You got 15 minutes.
No,
Yeah.
in college, it was a 5-minute rule.
He's got me turned off. All right. I did get a message back from Mark Crawford, and he apologizes. Something came up at the last minute, and he is not able to join us today. So you can certainly hang out if you want to, but we won't be seeing Mark. His apologies and my apologies for the no-show.
I didn't know if it just happened a different day or time.
Not to my knowledge.
Falta un timer acá, pero bueno. Okay. Thank you very much. Good morning. First day. Yeah, we need to wake up, prepare for the rest of the week. I hope you. Oh. More. It's okay. Let me again try. Good morning. Okay. The idea today is this session is part 1 and part 2. The part 2 follow this one. So you have 5 minutes to do. Go ahead or remain here and try to talking what I see in my personal experience in the field around ransomware. And what is my perception, my personal opinion, what do you need change in the mindset to attack that problem? Okay, that is the target. What is, what is the idea? This is the agenda, part 1, this first 25 minutes, part 2, the next 25 minutes. The first one, talking about VMware Cloud Foundation security skills, what your capabilities inside and what you need taking attention that there. And the second one, when you protect the workloads. In that case, of course, vDefense, you don't know, NSX security, now it's vDefense, but it's the same NSX security, but it's talking about protection against the workloads. Okay, that is the idea. First, the infra, second one, the workloads. So, starting with the part 1. Why? If you check the more common TTPs today around ransomware, you have several things. Okay, normally the people talking about common scripting, yeah, it's the big one. But when you starting to see, you see, okay, credential access. Second one, credential access. Third one, initial access. Initial access again. Initial valid accounts. Stolen valid account from privileged user handle the infrastructure. And second one, user the credential. In the end, you have a lot of people using problems around access. Maybe it's small parts, but when you see the problem, access to the infrastructure, privileged access is a big concern. Why? Because you lost the key of the kingdom, you lost everything. If the people go to the vCenter and has privileged access to create everything, doesn't care what you control. You need to put your eyes in that problem. When you see this, normally the people talking about ransomware thinking it's more easy. No. The recovery is enough. Usually, backup is enough. What you see the cost in that vision, recovery is the world cost. It's not only the IT cost, it's the reputation cost. It's a lot of things around, or maybe the company break out. So it's the best go only thinking recovery, or maybe start before to protect this problem. In the second one, the majority of the people thinking around ransomware is the same problem when you're talking the disaster recovery side, but it's a mistake. When you have a side recovery, disaster recovery, you have an RTO, you create some idea what is my target recovery. But when you go to the cyber recovery and you go to the backups, the question is, that backup is clean? How much need go back to find a clean backup? Or second one, my infrastructure It's clean. It's nothing hidden, waiting the next time. So it's not the same problem. So the backup, the recovery is not enough. If you don't believe, you have this big problem. When you take a backup, you need a clean recovery side, not the same side, a clean recovery side. Thinking, reinstall everything in your data center from the scratch. What is the time? Second one, when you're starting to check in the backups, what is the time to find the clean backup? It's possible you compromise an RTO in this situation? No. And that is a challenge. So ransomware recovery is not the same side recovery. And that means we need to change the behavior to recovery. When you see this all, because it's not new, Gartner cyber protection, you have a lot of things. And too much people thinking, no, I have all it for that protection. I have NSX security, or now BDFN recovery, BDFN firewall with ATP. And it's okay, yeah. I have network segmentation, distributed firewall. Maybe you have some protection in the behavior, you have NTA. Maybe you have something in the same host IDS, APS, but for us, distribute or gateway, but mainly distribute IDS, IPS, or include you have antivirus or malware prevention in ATP. But you see this appearance. So what is the impact? Each figure in the top in the pyramid has a small impact. What is the more strong impact? In the baseline. And you see, that is enough? Yes, it's a good point. But you see another things below, and that is BCF security. It's the infrastructure security. And you have things to restrict the physical and logic perimeter for the infrastructure. You need to handle the privileged access, that mean access. If you lost that, you lost everything. And you need to see what extreme behavior for the admin in the infrastructure. And it's part for BDFN NTP? No, it's part with the BCF. And that is more common problem. The people focus in the upper side, but forget the lower side. What is in the VMware Cloud Foundation? You have a lot of stuff. And the problem, why, Waldemar, is a lot. To make capability, yeah, that is the problem. You have a lot of capability to evaluate the risk and see what is the compensation control. It's security information. Yes, no thinking is I have a hammer, everything is an eye. No, you need to see the risk, you need to see the environment, understood, and create a compensation control, or maybe translate. You need something specific for your environment. You have a lot, yeah. If you are lost in everything, it's possible to follow the NIST. If you take in the NIST, you have, okay, taking that allow capability feature in BCF Foundation and put in different place in this side. Included in the version 2 is include the governance, area automation, cloud director. Now is two different things. See you tomorrow news about that, but you have a governance. You have a lot around. It's not just the hypervisor things. It's see the governance, the operation, the management for the infrastructure. When you start to see this vision, put focus in the infrastructure, you need thinking the first thing. Who access to the admin consoles? Who access to the vCenter? Who access to the NSX manager? Everybody for every place? Yeah, because it's easy. Yeah, it's easy for you and for the gangs. So we need to change the mindset. We need some point, some zone, restrict zone. When you put a console, a station to control, when you put enforcement and the tools for the admin guys to go to that sandbox first, and then from the sandbox to the admin consoles. The concept is everyone is possible access, but not directly. You put one cache to the admin because it's privileged access. It's no user access. You have the power to build and destroy everything. You need flexibility, but violate the risk. So starting to thinking, use a sandbox. Second one, it's not the same privilege, no privilege stacks and privilege. I am Waldemar. I have a user and authentication methodology for my email. Is the same risk with compare my access to the vCenter? Is the same risk to access to NSX Manager? Of course, no, because I have the power. So I need to create policy difference for authenticate no privilege access and special privilege access enforcement. And this case is starting to multi-factor authentication. And what is the problem? You have a lot of things today. Today you have a lot of capabilities inside VCF for that. But Waldemar, you said me use MFA for all users? No. For starting for privileged user. We are the admin. Okay, it's my duty. I need enforcement, my authentication. Maybe for the user and user for the email, no. But for that task, yes. And you have tools. Second one, you have in the VCF a single sign-on. So it's possible to create a single identity for all security, all privileged information. You have different options. It's possible to create one single sign-on for management and workload domain. It's possible to create a management, some workload domain, and other isolate. Or it's possible to create one management and other. You have options. In each option, you have the possibility to power access privileges control. You have the tools, you have the way. It's not enough use privilege with passwords. We need multi-factor. Use this more. From VCF, that 5.1, you have several new identity connectors. If this is HCDC Manager, it's possible to create this single sign-on for all stuff in VCF? Yes. And maybe it's okay for you use LDAP, Active Directory, or you name it, but also you have directly access to Okta, for example. Now, in the last version, you include Enter ID also. So if your organization has one identity provider for handle the access, it's possible to reuse that identity provider, not only LDAP, for this privileged use case, and combine this with multi-factor access. But, in the infrastructure, you have several static passwords. And you have a policy to rotate the password. But always, sometimes, the people forget to rotate the password. You have tools inside the VCF for enforce this rotation. For example, it's possible for the vSphere put one new password and deliver, of course, not that password. Note, that is more common password today in several customers. It's no bug, it's use case bug, human bug, yeah? Believe me, it's very common. And additionally, it's possible to rotate for other stuff. More, in VCF, you have a password management when you can provide times to rotate this password, follow your policies. So, in this case, you not need reminder. It's possible for you to automate that rotation. Because one static password is a password, in some moment, you guessed it. In the GANs, know that. When you change that, I'm thinking include BCF create a special account in the environment to service access accounts. No user, human user. It's a special account for handle a lot of stuff for API, no shell access, no console access. And remind that hiding for the guns and hiding for you. But why hiding for me? Because somebody taking your computer and see you keyboard, I taking the password. So hiding for you is you have a special access in the CDD manager to see it, but normally for the interface, graphic interface, do you know that exists? It's possible to change it, but you don't see it. If you don't see it, the idea is reduce the possibility the guns see you also. How people has SSH enabled in the vSphere? Don't answer. I know. Normally, in years ago, because you need something special access. But today, you don't need. You have the lock mode. But I need access. But why you open always the access? Not only in the moment you need, because it's possible normal behaviors lock down, and if some moment you need SSH, open it because you are aware, and then close it, not left open. So my first recommendation, normal use case, lockdown. If you have lockdown, maybe you have root VMware 1, 2, 3 on bank, but you reduce the risk than taking the weakness. So this is all use case. Lockdown is only enabled SSH if I need it. Okay? Second one, I don't see the names, but I see a lot of customers has the same VLAN to the management staff, to the workloads, and nothing controlled behind. Don't see it, no, not doing it, no names, don't see it. With VCF, you have the option today to split the management VLAN. Not only about the workload, the more use case for NSX network virtualization and overlays, also in the VM management, where you connect the vCenter, the NSX manager, and the NSX manager, and another VLAN for the host management, for the vKernel management. What is the idea? It's not the same VLAN. To go the vCenter to the vSphere, you need to go through something routing or through something firewall. Repeat again. You need to put some blockers, no flat connection for the bad guys. And that is included now, starting with VCF 5.1 in the API, but with the 5.2 is the interface graphic. It's optional, but you starting with Greenfield, nice capability. Usually, because remember, you have a lot of stuff for security, VCF, or vSphere. What is starting? What do you follow? What is the best? First thing, you have a lot of information in the VMware validated solution. Some people is all like me, remember the all VMware validated designs. What a recommendation. That recommendation build the idea to VCF. So now you have VCF, a structured infrastructure node repeatedly because follow one structure script for deploy. And above that, you have that things to create and improve if you needed the environment. So this doesn't start from zero and more. if you have vWorld vSphere Foundation, it's possible to take in similar ideas and apply it also, because in the end, it's vCenter. It's ARIA suite. So it's possible, yes. And that is it. You have a lot around. You remember the pyramid when you saw log access management to see extreme behavior for the admin user? Who is possible creating that? You have, and again, VMware Relay solution to handle different things around the security in the management side. To my admin is in PTO, but I see my admin log in at 4 a.m. from someplace in the world. It's normal? No. But I need to see it. I need warning that. That's my problem. You have tools to create that policies for automate, or maybe warning, or maybe you have showing the single sign-on against the Active Directory. You have a SSX admins group and put user with privilege. If you belong that group, you have access to the vCenter. I have a case, a customer, somebody create a new user in this group. Yeah, a new user, yeah. Who are? I don't know. Yeah, and you suppose some with them and ransomware live in that environment. You need to see the special things. You need to put the eyes in that privileged access. If you don't see that privileged access, because that is the early behavior before the long-time ransomware. And again, try detect and prevent and not only recover the problem. And also, if you have some problems around, for example, compliance, you have a lot of tools today, for a long time, it's possible, taking the recommendation. You have an spreadsheet, you have vCenter, vSphere, ARIA, NSX, everything. You have columns, PCI, NIST, wherever, and you see, okay, from the scratch, is compliant or no? Yes or no? Is no, what need change? And you have some scripts in PowerClip for checking that. And also, operation has a continuous checking this change behavior. Because you know starting the 0 day, but what happened in day 2 and the day end? You need remain. So you need use operation for a continuous compliance checking. You have tools, you know scratch. And again, if you have VMware vSphere Foundation, it's possible to reuse the same recommendation for that case. Don't start to create the wheel from 0. Use, these people is more smart than me, or you, because believe in this product, use the product, thinking the security problem. Maybe you need some adapt for your environment, it's okay, but starting for that. This is a good start when you don't have a framework for security, because improve the level in the security. Okay, this part 1 is just the infrastructure stuff. And believe me, this is the forget problem. If you checking the majority, the ransomware problems today, start with the access. And then go into the workload, but if you don't see what happened in the access, don't forget. You have now close to 5 minutes to left. You don't see the second part, but also the Wednesday, I had other 2 parts, 1, 2, talking about network security to Kubernetes to network security teams. It's no black box. And si alguien habla español y quiere hacer preguntas, después pueden hablar conmigo. Please. I don't need excellent, but you know. But please, yes, please. I need the survey, because the survey give me points with the team for apply the next year or to Barcelona for more things. And thank you very much. That is the first part. ¿Cómo andás?
Bien. Te quiero hacer una consultita. Tú siempre hablaste de acceso.
Sí.
Ahora, cuando son esos grupos que tienen privilegio, ¿puedo también setear
call for rewards because I don't have really official time for the question, maybe then. But you stay here for the second part, it's okay. Okay. Good morning again for the new people. Thank you for remain for the old people talking about the part one. We're starting now for the second part for this two-part session around ransomware experience from the field to ransomware. Okay, good. Sorry, one moment. Yeah, thank you. Sorry, it's alive. It's not recording. Okay, the part one was covered a few minutes ago. Now starting with the part two. The part two focused on the warlords myself. When I started seeing, I talking now VMware, vDefend, firewall with ATP, or for the old guys, NSX security. But this marketing change name normally, but it's the same stuff. Okay, what is the problem? When you're starting with VCF, you have a lot of things around. Mainly, you're starting in distribute and routing, including distribute routing in firewall, is part of network virtualization inside VCF. But the same platform has sleeping another capability, like in firewall, include distribute firewall, intrusion prevention, including malware prevention, and also you have load balancing. So you have security stuff sleeping in DVCF. Why I say sleeping? Because you need add-ons. For firewall, you need vDefend firewall add-on. For IPS, malware prevention, NDR, and other stuff, you need VMware vDefend firewall with DP add-on. And for load balancer, you need AVI load balancer add-on. You have the capability, but it's sleeping. You need pay add-ons. But you have tools. That is the thing. You don't need reinstall things. You need activate the capabilities in the platform. It's sleeping. You have two different ways to provide this stuff. Maybe one part in distributed way, the main focus, because you use an anchor in the vSphere for provide security, and more traditional way to get your firewall. You have different capabilities. This is focus distribute in worldwide running inside vSphere, and get your firewall for something connect in IP network, in vSphere or no vSphere. So you have both, but this is the big difference, the distributed way. When you starting, you have a lot capabilities, a lot. You remember, for the people see the first part, I explained one pyramid, and starting the base, the access, log, and the first step, network segmentation, this one. And when you think in network segmentation, I say, it's in the base, in the pyramid. So it's very important, very impact in the security. The other stuff above come then, but you need to start with the segmentation. And they go to more advanced things. That is the idea. You have two different add-ons. It's possible just starting with the firewall stuff, the network segmentation, and when you are ready, go to the second stuff in the upper level in the pyramid, the more advanced things. That is the way to define different protection layers, because when you starting to thinking in the old castle in the Europe in the middle, you have only wall in the beginning, but because you have maybe send arrows to the wall, nothing happening. But when you put a mounter or something more stronger, one wall is not enough. You need to create more walls in that castle to protect. It's the same concept. Each capability improve the level in the security and create problems to the gangs. because you have on only perimeter and you lost the perimeter, you lost. You need to create additional layers to defend and fight with the guns. And that is the idea. You go in levels. When you start in the first one, remember, network cementation, usually the people go directly, I need micro cementation. Sorry. You need starting with this one. Split segmentation to the management, to the DNS. DNS. The more common to extract information is use DNS. Use DNS for extract information. Why? Because my warlord sent a query DNS for somebody in the internet, and now my local provide internet DNS things in my data center. So it's okay go to the micro segmentation, but you need starting for levels. First one, go to there. No everyone need to RDP. No all warlords need go to DNS outside my organization. Starting with basic things. Who is my DNS in my organization? The warlords go only for that DNS. To internet, no. No for some foreign country in the world, no. It's the same for RDP. Who is need? You remember my first mention about the sandbox in a protection zone? Yeah. The rest of the world, no. And when you close that, you reduce the probabilities for the guns to easy access. When you fix this first problem, the second one is create production against developers. This is the production environment. This is developer environment. The developer environment need go to the production? Yes or no? No. What is starting? You need starting classify the warlord, the access. The first is not the tools. You need first, your problem is alignment. What is my access for production, developer, QA, or whatever, and create these growth zones, network security growths, to create production. Don't talk with QA, QA don't talk with production. And the last step is, okay, in the production side, I have a lot of application. Who application need talk with who application? Inside one application, what layer for my application need with talk? That is the last step, and that's micro segmentation. And that's the challenge. Not this one, because it's easy for this. Here, normally it's possible because I know what's production or no. That is the challenge. When you go at that, you have that, the old NSX intelligence or the VDefend intelligence now. It's go to the last step. No starting with this for create some firewall. No. The some firewall is, I know my asset. I classify my assets. I know who is production, who is QA, who is developers, wherever. PC, whatever. And you know who is the privileged access to DNS, RDP, or whatever. This is when you reduce that noise. Okay, now I have the application. And starting work on that. Mistake common, the people go there and create a recommendation with a lot of firewall, and they say, and stop it. If you stop it, the guns not stop it, attack it you. In some moment, see the space and go there. So you need change. And you had very good recommendation, but you need clean the space, clean the noise. When you finish the segmentation, you're starting with the upper levels. What is more common problem? Unpatching systems. Who is the more common unpatching system? The database. What? The more uncommon unpatching warlord is the database. Because I have first is the patching propose something wrong, and don't upgrade, don't patching. Okay, but you have a risk. You need another control or mitigate that problem because the problem exists. It's an patching. And that's the idea when you're starting with the distributed IPS and the virtual patching. What's the idea behind? Is I have an application. I now have an vulnerability, bug, name whatever. You have a risk. It's not possible patching. Okay, create in the hypervisor, because that is the idea that it's root. You have the vSphere. It's not just a cable. You have live system, the hypervisor, to create some rules to protect an unpatching system. In the meantime, I patch the system because this is a mitigation control, not the fixed control, because the fixed control is the patch. But in the meantime, don't leave the door for everyone. You use some control alternative, a mitigation control for that problem. And when you go above, several problems happen today in the security. It's not directly alignment with the files, malware, whatever. Too much problem today are fileless. So the traditional behavior for inspect a file is not enough. You see several ransomware is propagated for PowerClip script. Let me, what is wrong with the PowerClip script? The PowerClip is a malware? By itself? No. Or, for example, when you see the lateral movement, what is the tool? RDP. RDP is a malware? No. So, the file, the tool, is not the malware, it's the use is wrong or bad use. So, need to see the fileless, you need to see the behavior that creates chance to see it's a strange thing. So you need alarm. And what is the problem if you see only analogy behavior, false positives? What is the idea? Combine this one, and with this one. When they use VDefend with ATP, you have malware prevention capabilities. What? You have malware prevention capabilities. What is the technology behind? You have VMware tools in the VMs? Yeah. You have the all guest introspection capability for the other no-agent antivirus, all is right there. So you need only something to see what happened. And because you have port in the VMware tool, it's possible. First, taking the file, inspect locally. If you don't know it's bad on you, send a sandbox to run the code, remember the fileless, and see the behavior running, not sleeping. So in the end, you go some victim to infect. If the behavior is strange or is very close to another no malware, maybe I don't put the name today because a 0 day, but the behavior, it's not wrong. It's not good. So it's possible mark, alert, or in the next stage, prevent, save the file in the VM. How? Because you have the VMware tools. You download the file. When you go to save in the disk, this guy taking the file, see, no, wrong file, block it. So you have different tools inside to increase this problem. Okay, you have the first, the basic, create segmentation for privilege or needed diligence protocols, DNS, RDP, ACH. See what happened with that. Second one, split the zone, production, developers, and then go on the application. It's okay. Perfect way to start. but you need go above, because when you talk in ransomware, it's not just lateral movement. You need more tools, and the good thing is not see that tools isolate. Put something intelligent. Yeah, I know now is artificial intelligence everywhere, but no, it's machine learning because it's machine learning for several years ago, NDR, and combine those different sources to create a correlation. And this is when you're talking about NDR. And you possible taking the NDR and map with the meter attack tactics. And when you see this thing together, you have the possibility to connect the threat detection events, for example, IDS, IPS, maybe malware events, and the anomaly for NTI. And what you see, this is the UC. Collect different isolate events and see together to create really stuff. And you see the stage, the Mitre tactic in the below. And it's possible to go in deeper and see the timeline for that attack. That is ATP. That's NDR. So you have tools, yeah. You have something to protect what happened below, yeah. But also you have tools for go deeper. Normally, the people thinking alone with this and forget the infrastructure protection. Sometimes the people say, no, it's enough with the infrastructure protection and forget that part. And then you need both. You need to protect the infrastructure. You have the tools. You need to protect the workload. It's not segmentation enough. And not enough the protection in the perimeter. You need to go deeper and deeper and deeper to protect. If you don't put, you're missing something that, sorry, but the chance you take in a ransomware is higher. It's maybe not enough for all people thinking about this solution. Maybe it's possible starting with the security intelligence, remainder, the segmentation part, starting with the basic controls, the zone control for the environment, and then with the macro segmentation controls. Then improving the segmentation and try to use the behavior and collect everything source to create the NDR. That's possible. And now, if you go to some session this week, more deeper around Cypress, this one is Chain AI to this. Because already you have machine learning, you have information. Now it's go to the next step. It's taking the information and create something different to help the operation to the security teams. What is the other problem? You have a lot of tools, you have a lot of console, and you have a few people to handle. The idea with this solution is help a scarce resource human beings to more efficient and efficacious against this problem. It's not my session, but you find for this week, few people get deeper around the defense with ATP, I guess, and 1 or 2 sessions around that topic. Go then and starting to see. Take away. What do you need for my vision? It's my personal It's my personal opinion. It's Waldemar words, use or drop. It's just an opinion. It's no official words, nothing more. It's Waldemar opinion. Don't forget the management actions. We need to put eyes in the access. The managed access is the kingdom, the key for everything. If somebody has administrator, root, whatever name, privileged access to the platform, it's over the platform. Doesn't care what you have. You need to check that. Second one, don't start with the micro segmentation. Start for steps. Let me an iteration, starting with segmentation, the classic control, or the exchange protocol, or protocols or use or application that is used for sensing anomaly. Then go to split the environments. For split environment, I repeat, you need an access list and classify the assets. If you don't classify the assets, doesn't care the tool. The tool see traffic, but the tool don't know is production or developer. I know, or the team know. We need classify the access. And with the classifier, it's possible create some firewall. And in the end, go to the micro-segmentation for between application and inside application. Use Beamware Validate Solution. Don't create the wheel everywhere. Use something templates, good base. Maybe it's perfect fit with your organization, maybe not, but use it because it's a good point to start, and don't hide the problem. Don't see, no, the problem is not me hiding on the carpet, I don't see it. You don't see it, they can't see it. The problem that doesn't disappear when you don't see it. You need to see the problem and take an ownership. We need taking control for the problem. It's not possible to create my internal red, blue, purple team. It's okay. See people, partners help you. But you need taking responsibility for the problem. Don't hide it. Remember, prevent cost versus cost recovery. When you go to the doctor, they say, it's prefer prevent than cure. So prevent, please. And not for time, but you see in other tools around VCF, you have another option to fight this, especially when starting, for example, on Kubernetes stuff or the recovery parts. Question them, because for time, yeah, it's not possible. And again, repeat, for if you like it, this discussion, the next, what's next? I was talking about network security in Kubernetes for network security teams. See, that black box, no, it's black box, try to see what happened, understood with need for network security, see deeper. De vuelta, si alguien quiere hablar en español y preguntar algo, lo hablamos después. And it's just a suggestion, yes, for the survey, but yes, talking seriously, please give me the survey because the team evaluate the next application for my future explorers, so please, and thank you. I hope it's a personal opinion, it's not a marketing opinion, it's not nothing, but it's my personal opinion, but I guess it's possible you use for everyone. Thanks.
Is it ready? Are we ready? I can't hear. Is the speakers even going?
Can you hear us?
Can you hear us?
Yeah.
Okay. Good. Okay. Okay. Good morning. My name is Mark Cadies. I'm manager from Lenovo on the software side of Lenovo and ISG. How many people here know that Lenovo does servers? That's always a really good question, because most people know we do PCs, we do Motorola phones, but sometimes people don't know we do servers. So today we're talking about servers. So Patrick's from Intel, I'm from Lenovo. We've been doing a set of work looking at VMware AI, private cloud AI, and we've done some testing that Patrick's going to take you through, looking at performance of VMware AI in an environment, using CPUs, using accelerators, those types of things.
Yep.
In a lot of cases, you know, everything that's in the news, you're hearing large language models, you're hearing GPUs, really expensive. In a lot of cases, especially when you're doing inferencing, training, well, not so much training, but other things, you don't require all that GPU. You can get by with CPUs, and we're going to prove that to you today from the testing that we've done. A couple other things. Obviously, if you're familiar with Lenovo, Lenovo's in the server business. We have over 60 servers that can do GPUs and CPUs, and we have over 85 solutions in that area. You're going to see a demonstration of the testing and work that we've done. So I'm going to hand this over to Patrick. Patrick's going to take you through it because we only got 25 minutes.
Exactly. So we have just 25 minutes, and I will go very fast with the information. How about that? Yeah, perfect. Okay. It's okay? Once again? Maybe that? Oh. 1, 2, 3? Now. Okay, let's do like that. Okay, so we have material that takes more than just 25 minutes. I have a session about that, even with live demo after this presentation, so you have a time. You can. One, two, three. Yeah, it's loud. Okay. All right. So I will show you some steps which I did to improve AI workloads on CPU through building environment, deployment, AI components, and run example benchmark tests, plus some tuning on infrastructure. So very briefly, we are using meta models. In this example, this is Llama 2 with Hugging Face. Hugging Face CLI is used by IPEX to automate benchmarking, to automate deployment. And Intel Python extension toolkit is the repository that helps to deliver AI on CPU, on GPU, and run very easily. Here is even the information about Hugging Face, how we are logging, how we are making double check about logging after using Hugging Face tool command line. All right, 4 steps to prepare environment. First of all, clone IPEX repository, which is very simple. This is GitHub. Create environment. We can use Conda. You can use Docker container. I prefer Conda because that helps me to tune everything very easily. Then configure environment. We have a script which does everything for you. And activate environment. You are ready to run examples. Here we have 2 examples how to run AI workload LLM generative to precision, bfloat 16 and int8. We are using deep speed to spread workload to all of the sockets, all of the processes which we are exposing to virtual machine. That helps to saturate multiple sockets, create more sessions, and achieve more throughput. All right, let's jump back to the configuration. So all of the tests were done on Platinum, CPU 8490H, half terabyte of RAM. Storage, it is aligned with vSAN architecture. Then networking RDMA, AI Suite IPEX 2.2, Llama 7 billion, bfloat 16, input token, output token size, BS equal 1, and kernel 515 to expose AMX instruction to accelerate int8 and bfloat precision. And vSAN default policy out of the box, how we are deploying that, there is no change. All right, let's start talking about what kind of the steps I did to improve AI workload starting out of the box. So we have non-optimized environment, and I'm measuring second token average latency. So response from inference from a model. And our threshold is 100 milliseconds. So we would like to avoid the situation when the second token latency is above that. So we are still here, but the goal of this exercise was much lower with the second token latency. So the goal of the exercise to show that specific configuration hardware can give you better improvement of your results. I did 3 steps: platform tuning, this is step 1, VMware software tuning, and AI workload tuning. So out of the box, normal optimization. Step 1, SNC. So we have a situation when normally we are using non-unified memory access. VMware handles that properly. There is as well a different way of accessing to memory, so unified memory access. Long story short, unified memory access, you have just one memory controller and all cores or processor accessing to the memory through one bus. Latency is static, is repeatable, but bandwidth is lower because you have one bus and you can't extend that, you can't scale it. With non-unified memory access, we have multiple controllers. That's the default configuration, or multiple sockets. So you're accessing to the world in memory through jumping through memory controllers. Latency can be different. It depends when the specific word or memory information is, but bandwidth is rising because it's easier to scale, and you can achieve better results. Here's the diagram of CPU, but I added yet another feature on top of that. I enabled sub-NUMA clustering. What it does, it creates virtual domains. It's dividing CPU into pieces. In this case, I divided one single socket into 2 regions. That gives me possibility to run one AI thread here and the second an AI thread here and multiply results. At the end, that gives me 9% improvement. So this feature can be enabled in BIOS through methods on platform. You can pick between SNC2 and SNC4, and the SNC4 divides into four different regions. So at the end, we have 4 domains. On 2-socket platform, we have in total 8 domains. Okay, so enabling SNC plus P states, so power states, to improve power usability by VMware. That helps to achieve 9% of reduction. Okay. Now let's go to VMware directly. Not sure if someone from you were using that. Who are using latency mode? Yeah, error. I know error, so it's obvious. It is not hidden, but it's in advanced mode, in advanced option of virtual machine. Going there is latency mode. You can pick normal, high, and high with hyper-threading. What it does, enabling high reserves 4 cores to SXI, purely to SXI, and the rest of the cores are assigned to VM or VMs. There is spinning, physical to virtual, and those cores are static. They are not floating. The assignment is static. To enable that, first of all, you need to enable this option here, plus reserve cores in virtual machine and memory. This is mandatory. But Be patient. Please focus on that because my machine has 2 sockets, 120 cores. I'm using 116. Therefore, I need to reduce the number of 4 just for SXI. So enabling that and enabling SNC, we have a reduction 13%. So we achieved double digits, which is really cool. Then we are touching tuning of AI workloads, AI model, and we tested greedy algorithm versus beam search. Beam search is default one, and that gives you the most reliable results. I'm saying the generated result from LLM is fruitful. It's very complex, but beam search selects the k most probable token. So it's probing different paths, and at every step gives you the most probable result. Greedy is faster, but less accurate. Greedy choose the most probable token. So it's not going very deeply. It's rather shallow answer, but very fast. It depends from your infrastructure. It depends from your type of workload. It depends from your type of environment or even client, what kind of method you would like to use. If you would like to scale your environment and create multiple sessions without accuracy, big accuracy, you can easily scale that with greedy. If you prefer to have very complex results, beam search. But if greedy is enough for your environment, adding all of the options, so SNC, latency mode, and greedy algorithm, we are able to reduce latency, second token latency by 46%, which is very, very, very good result. And it is only on CPU. It is not on GPU. We generated that on CPU. In test, as I said on the beginning, we are using input token size 124, so 124 words as a question, and we are requesting 256 at the output. BS8 means we are starting 8 concurrent sessions at once. So more or less, we can compare that to 8 concurrent users. All right, and there's one thing, don't do it. I know that we are migrating quite often VMware environment from one version to the other. We are doing that properly, but sometimes, and I received that feedback as well, someone forgot to do migration of the hardware. So you migrated to the new vSphere, you have new vSAN, everything, but your VMs are still on old virtual hardware. With that mistake, you're not exposing all of the hardware capabilities from platform to virtual machine and at the end to application like AI. And then AI is not accelerated, what you are missing. And we did it with Lenovo. This experiment is published. You have a link here. You can go. But with AMX, this is result with AMX. This is without AMX. With AMX, it depends from the input token size, but we are able to scale up to 16 users per single server. Without AMX, we can put just 4. So density is lower by 4x. So please remember to upgrade even virtual hardware for VMs. Don't forget that, otherwise AMX, all accelerators won't be exposed to virtual machines. All right, my colleague. No, come on, Mark, it's about you.
So I'm going to scare him now.
Yes, I know.
So besides the work that you just saw, there's other testing that we've been doing with Intel. And here's 3 examples. If you'd like, you can scan these codes and see the methodology and the results in these 3 different areas. But you can see we've tried to mix up, some of it is VMware, some of it's on Red Hat OpenShift. Then we go add specific A models using like TorchSurf. So we've mixed it up a little bit. Here's 4 examples. So please scan those if you would like and take a look at them.
All right. So please take the survey. This is my blog. You can read about some research development that I'm doing myself or with a team. I'm blogging as well as The Expert. We have a booth in Hall B, so if you have a time, just come and see us. Plus, as I said, I have live demo after this session, so you can come and see what we have, what we are doing in live demo. All right, is there any question maybe? Is there a mic for, do we have a mic? Or, yeah.
I know a lot of the interest lately has been large language models, but
Sorry. Yeah, come on.
I know a lot of
It's not working? No.
Yeah, I know a lot of the interest.
No.
I know. There we go. I know a lot of the interest lately has been in large language models, but has there been equivalent research or benchmarking with small language models? I know that's a much more evolving set of research because of the more quantifiable ontologies involved, and that's a highly interest for specialized environments.
Yeah, that's a very good question. I tested rather small model because 7 billion is not big one, 80 billion like Llama 3, for example. So this is small model. We can improve the results after quantization to different precision, int 8. It's possible, and there was a foil about that. So if you're running on CPU, we are giving you advice to run rather small models, 7 billion on even 13 billion. It's fine. Anything above is rather hard to run without quantization. But that one was an example of small model.
Thank you.
Yeah. Yeah.
A quick question. So I might have missed this in the beginning. We're talking about. Oh, sorry. Ooh, sorry. We're talking about trained models already, right?
This is inference.
Oh, okay. Thank you.
Okay. Anything else? So I have coupons for questions. If not, then yeah. Yes, of course.
So I know these are CPU-based models.
Exactly.
Are there any modes where you share workloads between CPU, GPU? Have you seen any? Because I see the subnuma breakdowns for the domains. Is there any sort of cross-management between the CPU and GPU yet inside the model, or no?
Inside the model, no. When you are running, you are picking GPU or CPU.
Right.
You are not running on both. Rather, CPUs to control your process of running, and you're running the full inference on GPU. But the IPEX repository allows you to run both, not at once, but if there is GPU, will detect and run on GPU.
So I guess what I'm trying to ask is from a DR perspective, if I needed to, let's say I was running on a GPU model and my GPU crashes or fails, they're expensive, and I need to keep the lights on and switch to a smaller model, is there a failover model for the Gen AI with the CPU?
Well, loudly thinking is the scenario which can be addressed, but rather you should control that. You should have some mechanism to switch between GPU and CPU.
Okay.
Maybe you can have multiple VMs, multiple entries to a model, and just fail over. When one is down, then switch to the other, which is ready and waiting for responses.
Okay, so it would be on the model, like on my side, there's nothing in VMware I could use to configure the failover.
No, it's application level problem.
All right.
Okay. Yeah. All right. If that's all, thank you for your time.
this on your hip. You have to take your lanterns off because they'll hit the mic. Okay, awesome. I will keep these over here.
Yeah, we are thinking of starting like 2 minutes. Okay, I do hear myself. Okay. Hi, good afternoon, everyone. How are you guys doing? So today we gather here to talk about Overwatch. We will go about what led us to the development of Overwatch, the whole journey. So it's a super cool tool, which is like Google Maps for navigating the whole cloud infrastructure. So we will just get started with it, and we will start with some introductions. So hi, I'm Garvit. I'm a software engineer at Intuit. So if you guys pay any taxes, like any taxes at all, so $1 of that goes to me because I work for Intuit. And I recently graduated from Carnegie Mellon about roughly 2 years ago, and I love to be part of hackathons, develop, iterate, and develop some super cool products. I've been to a couple of hackathons like Hack Harvard, Yale, and it's just super fun, and I love that energy. Apart from that, in my free time now, since I'm from Bay Area, uh, I have picked up the real sport, pickleball, and yeah, that's about my weekends. And now, Hemant.
Hi everyone. So this is Hemant here, a staff software engineer from Intuit. So I visited more than 20 plus national parks. I like hiking, trekking. I'm from Colorado, Denver, so I like to go for hiking and trekking. I finished few of the 14ers there. So that's about me.
Okay, now I will take over. So I just want you to just squint your eyes and look at the screen and just try to figure out what is this data, what is this spreadsheet about? What do you think it represents? Right, you're right. It's like it's some data from a car, like car speed, what speed it is going at, like how much is the fuel level, what's the RPM. But why do you think is this better? Yeah, it's a yeah. So did you realize that in the previous spreadsheet, we were actually low on fuel. Now here you can see we are at 10% fuel. We would definitely run out, but it was much harder to see that. So if on a car dashboard, we would not have want a spreadsheet right in front in the like when we're driving. Why would we want something similar for our Kubernetes fleet? So this is essentially our motivation for developing this product. And yeah, this is definitely not how you would like your dashboard to look like, car dashboard to look like. And just in case you're curious, yes, it's generated with DALI, and I just inserted it last night. So now Hemant would be going over the problems which we were facing.
Yeah, so when you manage a large infra or the large number of clusters, so you have many problems, right? So like from the instance age or the AMI upgrades or all those security kind of things, how you can manage all those things, right? So that's basically the problem for us as well. We are running hundreds of clusters and thousands of instances, thousands of pods, thousands of namespaces in the Kubernetes space, right? So you need to be up to date on all the security stuff, and then when you can remediate, how we can remediate those security stuff, and again, it's a decision making, like when you want to upgrade your clusters and how you can make your fleet is up to date, right? So all those, like, we were having numerous problems, like how we can manage all those things at a go. Then we come up with the solution kind of a thing. So wherein, can you go to the next one? So So solution on the solution of those things, right? So we have numerous data, right? So those all across the systems. So we created the batch job, like which can take all the data from the different sources, massage that data, put it in the proper format, and push it somewhere, and then build a cool dashboard, like Garvit was showing some time back, like on the car, right? Like how you can see when you are running out of the fuel. And that's what we did. Like, okay, get that data, massage it, push it at some place, and then build cool dashboards on that. So you can, on a click, you can see like, okay, how your infrastructure is, where are the problems, and before you get to those security issues, how you can remediate. So you will be up to date on all those things, right? And also, it helps for your capacity planning because your infra is growing day by day, right? Because you get new workloads on your clusters, your infra needs to be capable of accepting those workloads. So how you can manage, right? So with this, we are like, with this our dashboard, we predict that like, okay, so our infra is growing at this %. So how we can match that infra with the additional capacity. Again, like when we put those resources, right? Another challenge in the cloud space is like, okay, the cost. So you have a lot of wastages. So with this, you can say like, okay, my clusters are growing this capacity, with this capacity, and what are the wastages on those, and how I can minimize those wastages, how efficiently I can use those resources, right? So we can take those things with the Overwatch as well, right? And it also, it tracks all kind of metrics. It's again tracks all kind of instances, what fleet is working on which kind of infra, all those it captures. Okay, can you go to the next one, please?
Okay, now I know you have been seeing a lot of text, so I will show you some more text, but I promise a pretty looking dashboard is coming soon. So I will just go over the stage 1 of the iteration and basically what were the features of the dashboard. So we needed a couple of things, like there were key problems which we wanted to solve for. So like one of the main things which we wanted information is about basically our distribution of clusters over various regions. How like what is the generation of our instances which are running, region-wise distribution of the AMIs, and like basically the architecture of our whole infrastructure. So we collected all this information, represented in a nice graphical format, so it is much more easier for it to digest and basically drive insight and take some decisions. So I will basically now go over how Overwatch basically exceeded our expectation, and and we are actually using it much more than more than we expected. So all the data which we got from multiple sources, we kind of put it on a dashboard. So I will just go from left to right, where here you can see, okay, let's say I have to for compliance purposes, we have to stay within certain range for our AMI age. So if I want to know, okay, in next 30 days, I'm going to run out of this specific date, what I can do is, okay, put 30, 50 and click on the button, and all the data would get modified right on the go. So now I exactly know what instances should I rotate, which clusters are being problematic, and so on. Then let's say if my instance has been like launched for quite a while and it has been like more than 25 days, boop, I click the button, I know, okay, this is going to run out, and it has to be within our security limits. Then if you see about the cost optimization perspective, like if you have used Amazon Web Services or like any cloud infrastructure at all, there would be certain instances where we would have terminated the instance, but it would still show terminating, but it never terminated. But there's a cost associated with it. So we noticed that there was many times this was happening. So we can decide basically a duration. Okay, let's say if the instance does not terminate within 30 minutes, then it means that it's pretty much in a stuck state, and basically we can send that data to AWS and get money back for it. And we are talking about 5-7 instances, it probably does not matter. But when we're talking about 20,000 plus instances, and this happens regularly, then probably you're like talking about hundreds of thousands of dollars in the long run. So that's a very key metric. And this dashboard also helped us with migration and migration of our instances. For example, at the top you can see Gen 5 and Gen 6. So for cost perspective and performance perspective, we basically migrate our instances, and this comes very handy to track, okay, these are the instances which have been migrated, this is the stage, this is our pending work, this is our architecture, and so on. And similarly for the GP2, GP3 volumes as well. So it's just you make the click and you get all the data right in one go. Now this was actually very useful for us, but now there was stage 2. There was one lacking part. There was one specific improvement which we specifically wanted to make. That was that, okay, we have the current data about our infrastructure, but one more thing which we wanted to have, make the use of real data, was historical comparison. We wanted to see how our infrastructure is growing over time. Let's say if a tax peak is coming, because none of you file your taxes on time, you wait for the last day. So definitely we want to scale, or we definitely want to scale at the right time, at the right moment. And since we will have some historical data, we will be able to predict right in time, okay, this is the capacity which we want at that during the particular peaks. So with historical data, we came up with a minor improvement. It's pretty much the same dashboard. I know it's blurred out, but it's pretty much the same data. What you can do is you see a date field. You can basically choose a specific date, and it would basically show you data for that particular date. And now you can see the comparison, how you're growing, shrinking, make predictions, and basically pretty much like it eases the whole process of like not making a ballpark figure in the future, just relying on some real data which is from the past and come out to be very useful. Now Hemant would be talking about how we are actually using VMware and how it's actually helping us.
Yeah, so what are metrics we get, right? So most of the metrics, we push it to the Wavefront, like from different components. And then based on those metrics, we build some charts and then see what, how is our cluster health, or how is our cluster capacities, where we are using how many instances and what kind of instances. That data we get it on the Wavefront. So that data, what we do is like Wavefront, we push that data to Wavefront, those metrics, and also for the Overwatch, to make sure we are on the right track with all the points what we get, we compare that data with the Wavefront. And we also consume some of the data from the Wavefront, and that enriches our Wavefront dashboard. So this is some of the example, like what kind of data we get it from the Wavefront, so which makes sense to us, right? So number of active nodes, or the CPU utilization, memory utilization, cluster memory usage, and what capacity are they are. So I will briefly go over the architecture. Like it's not too complicated. Like we have a different system, different sources from where we are pulling the data. So it is fairly simple. Like we have we get all the metadata from the Amazon EC2. So we are on AWS fleet, most of our clusters. Then we get some data from the Wavefront, some of the metrics, key metrics, which are related to the instances. We have our own Kubernetes service, Intuit Kubernetes service. It's called as the IKS. We connect to the IKS to get all the clusters, whatever are the clusters are there, what accounts they are in. And we have the AMI data, wherein when that AMI is created, when it's due for the next renewal, and all those things. So all this data, we have it in the raw format. Earlier, we used to, get that. We have to go to different resources to see like where my cluster stands with perspective of the security and compliance, right? So we used to do that manually. So what we did, we wrote a Python library which gets all the data from all different sources. It matches all those data. We flatten that data and then push it to the data lake. So why we are pushing it to data lake? So if somebody in the company or other teams, right? They need to use that kind of data. They can use that data from the data lake. So we created one extra stream for the others to use that one. And on that data lake, right? So we built the Overwatch as a nice dashboard, like what Garvit showed some time back, to get all that data and build all the dashboard what we need for all our use cases. And the same data can be used for the other teams as well for their different use cases. This is fairly, it's not that complicated architecture. It's just simple Python library, getting all the data, massage that data, put it in the proper format, push it to data lake, and build a dashboard. And then data lake, why the data lake there, right? So again, I said like flattening data, pushing it so other can take the advantage of it. And then if you want to do the historical comparison, right? So we need to have some source where we can see like, okay, yesterday, how was my cluster capacity and how is today, or the when was the last time, what was the peak, and during the tax season. So we need to make sure like our capacity is at par, and then we compare that. Okay, last tax season peak time, what was the capacity, right? And then you can compare that data, and then ahead of the peak, you can just bump up your capacity on those clusters and get going, right? So that's about the architecture. Next one is the Garvit will go over the benefits.
Yeah, so we have pretty much talked about benefits, but there's one particular thing which I would like to highlight. I know it automates stuff, it streamlines the whole operations. There's historical data. You get to see everything out of place. And of course, it's like a dashboard for your whole Kubernetes fleet. But the last point, 100% compliance. When we did not have the Overwatch dashboard, we were nowhere near even in compliance. Like forget about 100% compliance. So with just a better view and like the key things which we wanted to focus on, like AMI age, determination duration, we were able to see well in advance what is coming on our plate and basically able to assign the request to the right people or take care of it well in time. And this is the perfect place where we think Overwatch has given us the most value for our buck is 100% compliance. And yeah, there are a few improvements in our mind, definitely, because now that we are done with the stage 1 and stage 2, stage 2 was having the historical data on the plate. We are not just static. We can see, okay, based on the past, we want to make some improvements. So for our next steps, we want to add some more specific metrics which could be related to related to cluster upgrades, because there's tons of decisions which we still make for our cluster upgrades based on this dashboard. So it would be nice to have some pertinent data related to that, and we can make those key decisions. And one another area which we would want to focus on is basically cost saving opportunities, especially like checking out the auto scaling groups and how well provisioned, if we are running over capacity, how we can just trim down and stay within the limits. And this will definitely get better as we have more data and we are able to see more patterns. The second improvement which we want to make is basically all the UI which you saw was based on ClickSense. So this ClickSense UI was really helpful for us in putting up all the metrics really quickly on the go. Like within a month we had like from nothing to a very well functioning UI, and it was just possible because we had the flexibility of ClickSense. It's like drag and drop. But now that we know what we want and we know where we want to improve, it would be much better to have a flexible UI which can be like a React UI where we can use some custom components and basically make it much more responsive. And as our data grows, we are already feeling that with the historical data, it's already slowing down. So this is the next step which we are actually working on. It's in progress, and hopefully next time when you come and visit us, we will have a React UI. And now we are open for question and answers. If you have any questions, feel free to ask. Yeah.
Using machine learning or AI to help you with the predictive
Yeah, so as we have this all data, right, and we want to predict those things for a number of occasions, right, like the when the peak and all those things. So we are working on the, using the AI and machine learning to predict that one. So we already in process of that, and we will be launching that in next month, mid of next month, where we have a good result. As just the, we don't want to over budget our capacity or very low as well, right? But right now it's giving like 5% plus or minus. So that's the results we are getting right now.
And the interesting part is that at Intuit we get like a week where we can iterate and basically play around with anything you want. So it's like a week of you choose the project, you choose the field, just do whatever you want. Just it's like it's like 5 days of hackathon. So the project which we actually worked on was like how we can use machine learning algorithms for predicting the capacity. If you guys don't have any other questions, yeah, then that was our session.
Okay. See you as well.
Oh, okay, sorry, go ahead.
So, ready? Okay. So, is Click part of your stack? And that's what you guys are using to make all this magic happen? Or is Click a requirement of the maps, of the environments you're trying to make maps up? Are y'all using Click?
Yeah, we are using Click. So it's basically a representation of all the data which we have, and you can use anything. Like you can also maybe use Tableau, or you can also create your own React dashboard, or maybe like make it part of the Elk stack and get some even finer details. So we are using Click because it's really fast and quick to iterate and make the changes, but it's just an idea. Use
Right,
whatever
so-
you like.
But so, like, if somebody else wanted to use your product, they wouldn't need Click. They could just use your product, and Click's part of your stack.
Yeah.
Right. Okay. Got it.
It's just the UI stuff, right? So data is there, it's already flattened. So you just build any kind of a UI, whatever you want, right? Yeah.
Awesome. Thank you. And don't forget to connect with us on LinkedIn. Thank you.
Okay.
Yeah. Okay, I found out that you like that fancy name. I am Konstantinos Kaminaris. I am from Greece. If you don't know where is Greece, just Google it. It's the best place in Earth. And the name is because, first of all, I would like to thank you for being here. I am excited to present here in Las Vegas. And of course, I'm just about VCF, okay? Okay, so when I was doing some presentation in Europe, I've asked my mom, what do I have to present? I'm going to present at Las Vegas. And she says, why don't you present about VCF? Of course, my mom doesn't know about VCF, not at all. She just knows how to open and close the smartphone. And this is way up for him. So let's talk something about VMware Cloud Foundation. This is let's say in French name, potpourri of what I found out about VCF and what is nice about that. VCF, first of all, is a set of tools and technology that provide us a software design perspective into our data centers while managing our private and public cloud with this tool. One of the best things in VCF is that there is a consistent infrastructure and consistent architecture across the entire environment on all the sites that you can have. Come and join us. It's a single multi-cloud farm. You can see that I am a QR coder. So if you want to scan it, it will show you the VCF release, and in the other slide, you find other information. So as a single multi-cloud platform, it gives us hyper-converged infrastructure and oh, hello. And that modernizes our data center and our containerized application. Sorry about that. I just have my water there. Yeah. Okay. So with VCF, we can separate our workloads into management and application respectively. This is where VMware products works better together and can give us an, let's say, a way to the benefits of both of public cloud and private cloud, and we can while keeping our data secure and applications. So, okay. Okay, let's change it. At VMware downloads, Broadcom now, sorry, it has 66 downloads, and all those products that you can see is only for managing our private and our public cloud as well. The releases of VCF, if you do not know, it starts from 2.1 back on 2016, the initial, and now we have moving up to 5.2, and till those years, there adds a lot of innovative things. So, do you know that VCF has open source also? Yeah, it has. And you can find out that in each version, on the previous slide, you will see Broadcom's download. In each session, there is an open source tab where you can find the open source file and, of course, the license, but it's not for production and it's only for testing and labbing, okay? So let's speak about the bill of materials of a VCF environment. VCF delivers a natively integrated SDDC stacks that includes SDDC Manager, which is the tool that we can automate all our tasks from bringing it up and till our provisioning, patching, and upgrading, and can help us to simplify our day-to-day task. Then we have vSphere, of course. You all know vSphere. It's the virtualization that transforms our data centers into aggregated computing infrastructure that includes CPU, storage, and networking resources. Of course, then we have vSAN and vVol. This help us aggregate our local and direct attacks storage devices into one pool of, let's say, shared storage across all our vSAN cluster to all our hosts, of course. VI workload domains support NSX and also support NSXT platforms. This is the way that you can have networking and security functionality into your environment. Then we have ARIA. VMware ARIA Lifecycle Suite is, with that tool, we can deploy ARIA operation, ARIA automation, and ARIA operation for logs. And with this, we can determine which version of our products are compatible with our VCF version, and allows us to upgrade and install and patch only the supported ones. Okay. Then we have with using VMware Tanzu integration with VCF, we can deploy and manage VCF Tanzu, VCF with Tanzu, and make our VCF into a platform that runs Kubernetes into our hypervisor layer natively. So we're now at the 5.2, and it has new cool features, of course, and includes integrated data service capabilities and native Kubernetes, where we can that supports and VMware and VI workloads into a single platform. These features are aligned with the three key strategic pillars. The first is modernized data center. The first feature is, of course, VCF import, where we can use it for converting and importing our vSphere and vSAN environment into VCF instance. We have vSAN Max support with ESXtrust cluster that offers high storage efficiency and resilience. We have offline depot. This is a nice feature because it can update our, let's say, isolated and air-gapped environments that cannot be reached other way. We have GPU enhancements catered for AI and machine learning, of course, demands. Then we have isolated workload domains with shared networking. Just to ensure that we can optimize our utilization without compromising security, of course, because they're isolated. Okay, let's put that down. Then we have VMware Cloud Foundation Edge, where we can extend our capabilities into all our edge location with a network assessment and optimization report that provides insight in order to optimize our network performance. Centralized license management, where we're all struggle to find out how we can manage to license our edge and our VCF environment. And the amazing HCX assisted vMotion, where we can move our workloads or our VMs from our private cloud to the public cloud and vice versa. The second is cloud experience for developers, where we can use Tanzu Grid as a standalone service to accelerate development cycle with cloud admin dashboard and Latchpad that it helps us managing our resources and automated oral tasks with self-service VCF automating for DevOps. Also GPU summary for private AI. Adopting virtual networks reduce the complexity of using all those networks and also help us and give us the possibility of adopting networks segmentation and management. With increased log analytics, the new feature of I/O chip analyzer cluster provides critical insights for optimizing AI and big data workloads and vSAN ESA file share. The third pillar is security and resiliency. And now you can see live patching of an VCF and ESXi is doing much faster with minimizing operational and the disruption, and also without taking too many services down, while the host is into a partial maintenance services. That means that some of our VMs or workloads can run. We also have redundancy and load balancing at the edge. We have Entra support, Entra ID support. We have SIEM integration between East and West ransomware, and the amazing AVI load balancer integration. Some labs are having that. And also, let's say we have dual DPU support, and supporting a data processing unit provides either the ability to have the high availability of DPU, where there will be an active and standby DPU. So if there is an outages, then all workloads passes to the standby DPU, or we can have double the bandwidth by utilizing our DPUs and providing double the network throughput. With that feature also we have vSAN data protection and the on-premise NDR threat tracking. This is nice security features. So if you want to start from somewhere, if you want to start a VCF instant, this is where you have to start. Planning and preparation workbook. It's just an Excel, Microsoft Excel workbook where we can gather the inputs required in order to bring up a VCF, workload domains and workload management, and of course, VMware ARIA Suite lifecycle. It also provides us guidance on the requirements for additional components like Active Directory, IP addressing and networking, or class or certification that can be added into our VSVF environment. As you can see all those final tabs, you can see that they are the VCF validated solution. So these are well-architected, technical validated implementation built and tested from VMware and VMware partners, and can provide us guidance. They are designed to build a secure and high-performing and resilient and efficient infrastructure with VCF. And each solution provides us guidance of how we can design and implement its solution. They divide it into two major categories: the on-premise validated solution with identity access management, developer-ready infrastructure, health report and monitoring, intelligent logging and analytics, intelligent operation management, intelligent network visibility, private cloud, site protection and recovery, and advanced load balancing for the on-premise world. After that, we have the second category, that is high cloud validated solutions that provide us cloud-based protection solutions, cost-based ransomware recovery, and of course, cross-cloud mobility. Okay, SDDC Manager automates and implement tasks for some of the design decisions that we saw. But for the rest of them, we have to do it all the tasks manually. So, in order to make it a little bit faster and with a more efficient way, in order to automate it, also the other tasks like site protection, there are Microsoft PowerShells commandlets using an open source module as code-based to complete some certain procedures in its SDDC components user interface. Now we are in the version 2.11. There are previous versions because this is the latest, and each one, of course, this is the QR code where you can find the PowerShell solution module. Each of its version, it has a list of supported platform of VCF, a list of supported operating systems, and of course, module dependencies to run these PowerShell commands. The fancy is that we can reuse PowerShell commands by replacing the sample commands that are exported from the VCF planning and preparation workbook. That's the amazing thing. So, the other tool that we have is supportability and serviceability. This is called SOS Utility. This is a command line tool that helps us make some to run some health checks, either and collect logs from our VCF, including components, tasks, services, and software components, and can be generated. These logs can be generated into our preferred directory. So you can. This is the page of SOS Utility. It collects logs from ESXi, vCenter, SDDC, NSX, workload domains, ARIA, and it has some test logs for verifying files. We can run SOS Utility into the VMware Cloud Builder, which is the tool that it's an appliance, and we can generate a support bundle in order to help us debug or bring up VCF instance. This is the tool that you need if you want to debug it. Last tool, it's a VCF diagnostic tool. This was formerly known as vSphere Diagnostic Tools. It's now a multi-product diagnostic tool, sorry for that can be run into our vCenter appliance immediately, directly. It executes a series of checks, and it provides us with a report, with a user-friendly report, with fail and pass and warn about known configuration issues. It also provides information from certain areas, and that will help us detect inconsistencies more easily. It's a read-only script, so it does not make any changes. It's into our environment. It only adds into our log bundles information and logs, and there are no passwords recorded. And of course, this is a code, and it is non-compiled, and this is done for us to review it easier. VDT2 has written ground up in order to evolve from, let's say, a Python script collection to a Python-based health reporting framework. So you have an existing VMware Cloud Foundation. You can perform a sequential, or let's say a skip level upgrade for VCF 0.2, but only from 4.5 or later. So if your environment is previous than 4, sorry about that. This is the previous about VCF 5, but you can find the upgrading here, so no problem. I was saying that if your environment was previously than 4.5, then you have to upgrade it to 4.5. So the first step is to download the bundles that you need to be upgraded, and then when all the bundles are downloaded into our SDDC manager, we have to upgrade first the management domain, and after that our VI workloads domains. Okay. So VCF training is something that must be done. You can work in order to learn some things in VMware Hands-on Lab. It has all the tools. It has about VMware ARIA. It has about SOS. It has a new VCF health framework. And of course, you can read about VCF documentation, and we have VCF communities where we can help you build a VCF or debug it. So, Holodeck Toolkit. Doing training and development directly into our VCF environment can be dangerous. So, it is important for us to have, let's say, a playground where we can, test changes and updates without having the risk to do a mistake and then our VCF falls down. This is minimize the risk of all that, and it can mimic our production environment as much as possible. That doesn't mean that you have to build the entire environment with the same hosts, but only with one host you can have all your environment. Just it has to have the same architecture and the same design. Are you productive in order for that to work? So VCF provides an easy way to deploy VCF nested labs into that environment. So you can play as long as you want. Last, we have license calculator. Who doesn't struggle with licenses? We cannot understand how is that going. So this is a PowerShell script command, that it is created from VMware by Broadcom and help us let's say, familiarized with the new subscription portfolio. We can run simulation in order to determine the subscription license required for VCF, VFAN, and vSAN. This was my last. Thank you all for being here. I'm Konstantinos Kaminaris. If you want something, you can find me at the VMAG. I'm a community guy. Please don't forget to take your survey and, of course, to stay connected with Explore. Thank you. I have to tell you that you can have some reward points if you want to ask, but you can ask me afterwards at the VMAG booth. Thank you, everybody. No, no worries. It was going to be a 45 minutes presentation, and after what they said, 24, and I skipped some. Yes. Oh, hello. How are you doing? No worries. No worries. Just.
Yep, we'll do a check here momentarily, and we'll make sure it's all good. Ooh, sounding good, sounding good. Yeah, yes, that, yes. For some reason, the clicker's not working. Let me know when. All right. Welcome back, everybody, to VMware Explore 2024, to the community sessions. My name's Tony Foster, and thank you for coming to Empowering Virtual Environments, the vGPU resource scheduling plugin. Well, sort of. I sort of made a mistake. Got a little too far ahead of me on my skis. We're going to talk about all this here as we go through the session. And so, yeah, was originally going to talk to you about doing this as an API, because still really cool. You can still do a lot of cool stuff with a API. Well, I ran into a problem this morning. So we'll try that again. Yeah, we're just going to talk about vGPU scheduling. And reason for that is had a little bit of a problem with a lot of things. I evidently upset the IT gods. I am Tony Foster. I am the Wonder Nerd. So sometimes you will sit there and go, oh my gosh, that is absolutely amazing. That is wonderful. I can't believe that nerd did it. And sometimes you will go, I can't believe that nerd did it. Why did he do that? Anyway, here's my little bio. I've been virtualized since the 2.0 days. You can find me on X, Wonder_Nerd. You can find me on LinkedIn as Wonder Nerd. If you hadn't guessed, Wonder Nerd sort of a thing, just in case the cape didn't give it away. So let's talk about what went wrong. Original plan was we were going to talk about plugins and how this thing just slides right in and you get to control your virtualization of vGPU resources. Well, I lost my plugin doc because there's a doc that I found that actually makes plugins a whole lot simpler than what you find in the vSphere documentation. You just sit there, you follow along, and you can skip a bunch of the security stuff. Completely unsecure plugin, but you can skip it and you can get good results with it. I managed to lose my bookmark. It's not in my history. It has disappeared from my system. So, backup plan, API. Awesome. We can do the API. Flask broke this morning on me. I had a import that I was setting up. That way I wasn't showing everybody all of my login credentials into my home lab vCenter, because no one wants to share all their credentials with all of their friends at Explorer. There's no telling what might happen. So I was like, shoot, what's going on here? What's going on here? I rebooted my box that the plugin / API was running on. Still didn't fix Flask. Okay, easy enough. Let's try a couple of things. Still could not get it to work. So I'm like, okay, I'm going to record a demo and show everyone how this works just purely out of Python. Tried to go run the code that was working flawlessly last night. It was even working flawlessly this morning before Flask broke. I rebooted my system to try and get the Flask service to work correctly because it wasn't coming back online after I made one simple import change in my Flask app. Now my code doesn't run correctly either. So this is probably going to be one of those sessions where you're like, wonder why he did that session. Darn nerd. So we're going to actually talk about how this thing functions and why people want to load balance and how you can use it in your environment, along with a timeline on when you're actually going to get code and everything. So all of this is going to be available on my GitHub site. So github.com/wondernerd. It'll all be there. Working code will probably be up tomorrow, as soon as I can find out what changed after that reboot. So anyway, there are lots of different ways to solve resource scheduling of GPUs. Johan van Amersfoort, a friend of mine, has a very nice section in his VDI Design Guide Part 2 book that walks through his way of doing resource scheduling with vGPUs. So you can go out there every so often. ITQ will offer it for free, so you can download a free ebook of it. Awesome material. You will find my name in there. Johan grabbed me to do a section in that, so you can go out there, look at that, and there's some great material on this and why you'd consider it in your environment. He's actually done it for the Netherlands Cancer Institute, and there's some great content in there. Now, the way I approach it is a little bit different from how Johan approaches it. And if you think about your resource usage, especially with VDI, you'll see that typically with VDI, you have a peak when users come in and log in. All of a sudden, all of those VDI systems that have GPUs assigned to them start getting turned on and consumed. And that lasts throughout daylight hours. And then about 5 or 6 o'clock at night when people are going home, it starts tapering off. So we have a nice lump in there with a lot of idle times for our GPUs. Now, if we track our idle GPUs and stuff, it's the exact inverse of what we have running inside of our normal environment, or exact inverse of what we have for our utilization. Have lots of idle hosts at the beginning, lots of idle hosts at the end, not a whole lot of idle hosts in the middle. Wouldn't it be great if we can capture those GPU resources and use them for our AI training or ML, DL, or anything else that requires a GPU? And that's the whole idea behind this plugin that I've been working on. In fact, if you're interested, you can go out today and download my PowerShell scripts that do the exact same thing. So those are on my GitHub website. You can see those on GitHub. There's been a lot of changes with the Python code that I did and this API, because now you can actually go in and take advantage of some of the new features that have been built into vSphere 8.0 update 2. So anyway, we're going to take advantage of these underutilized resource periods. That's what the plugin does. It sits there and monitors our usage of one type of machine. As that machine rises and falls, it adjusts our running machines otherwise. So if we have an AI system that is a secondary program, we can turn on the AI machines to use that GPU when our VDI resources are low. So an overview of how this works. It's actually a pretty slick little simple logic loop. It sits there and goes in, basically queries the environment and says, how many GPU resources are free? And then goes in and says, hey, you told me the minimum number of GPU resources you wanted free on this system is 5 slots for your VDI to start up. And you have 10 slots free. So I'm going to fire up 5 systems that can consume those 10 slots, or consume those 5 slots, leaving you 5 slots free. A VDI session or any other vGPU workload comes along and needs to use that. The loop sits there and detects that a new workload is started up on the primary side, and it goes through and suspends your current AI workload, which releases that GPU for availability back into the environment, maintaining that balance of I want 5 free and I want my primary workload to consume GPUs as much as possible. So that is the overview of the logic I apply when doing resource scheduling. So here's the actual idea of it. This is more the Venn diagram. So we have resources. As our VDI stuff expands, our compute resources shrink till it gets to a balanced state. Once we can balance out our workload, it's going to sit there. It's going to stay in a happy state until it becomes unbalanced. Then it's going to start shrinking stuff down and making resources available. So really cool. And I just realized I walked through that entirely backwards. So it starts by suspending as VDI kicks in, reaches a balanced state, and then as VDI goes away, the compute takes over and gets to get larger. Now, one of the things I get asked a lot with this is, what sort of workloads can you run with this? You keep talking about VDI. You mentioned all this VDI stuff. VDI is definitely a primary use case. And the reason VDI is a primary use case is, A, it is very cyclical. During the day, it goes up. At night, it goes down. So it makes it an ideal target to try and capture back resources, capture back any funds that you have invested in those GPUs so you can maximize utilization of them. The other part that makes VDI nice is there's an external control mechanism that is turning on and off those VMs for you. That doesn't mean you can't do it with AI. There are plenty of scheduling tools and stuff for AI workloads that will let you schedule your AI and bring machines up and down. So you could have two variations of AI running in your environment and have those scheduled, and this will work with it. Eventually, you will probably be able to have multiple different types of workloads running and let it schedule accordingly against all of those. And then anything that uses a vGPU. If it's got a vGPU, we can work with it. So it's really powerful in that regard. That said, what the API was going to look like until it decided not to work for me today was it was going to be real simple. And there would be a lot more in here, but I decided just to go with the main one, which was balancing. So literally, it would be a one-line curl command with a JSON string, similar to what you see down there in the bottom. And it would sit there, scan your environment, figure out what GPUs all of those virtual machines you have defined there. So the way the JSON works is it wants to know what cluster you're running this against, because it is a cluster-wide system, so it'll work across a cluster. What the primary base name is, so whatever name you assign in VDI or AI workloads or anything. So in this case, holding VM, what the base name of the secondary VM is, which is compute in this case. Your formatting for the end of the string. Is it all zeros across there? Is it the letter T? Whatever the formatting is for both primary and secondary. The starting secondary VM number. So does it start at 0? Does it start at 1? Do you start at 23? You can put all of that in there. How many secondary VMs do you have? And how much spare capacity do you want? I have a small home lab. I run 2 P4s and an L4. So that is the size of my home lab. So that's why my spare capacity is so low. The plugin, and again, code will be available hopefully tomorrow when I find out where the bug is. You can sit there and each workload type can run different GPU formats. The code actually goes out and looks at the GPU formats for these items listed in the JSON and determines what they are and how they balance against each other. So it'll figure that out. It'll also allow you to take advantage of mixed GPU types, which is a new feature that was introduced in 8.0 Update 2. So you can actually sit there and run different profiles on the same vGPU. Now, there are some limitations that go along with this plugin, or the API, or anything else. Right now it is for lab use only. Like I said at the beginning, I didn't want to broadcast all my credentials. There are security things that I know exist inside my code that I had not had time to take care of. So you don't want to go using this in production and blasting an account that has permissions to control virtual machines all over the place. So right now it's lab use only. There's no emergency brake on this. So one of the things people ask for is the ability to stop a balancing operation if they discover that something isn't what they expected. They misset the minimum number, or performance isn't where they want it. So there's no emergency brake in this right now. It is not optimized. It's not multi-threaded. So the code is a little bit slow, but it was the best way to do it. And I hadn't gone through and set timers to find all the slow stuff. Error correction and detection is hit or miss in the code. It's actually really good with the strings and the names and everything. So it hits those without a problem. You can do some pretty wonky stuff and it'll correct it, but it won't catch everything. And then there's also an object bug inside of vSphere that I need to report that I discovered yesterday or Saturday, one of the two. And it's under the host.config.graphics info. And basically the GPU, which is what that's reporting on, doesn't update the running virtual machines on it as fast as the rest of the environment. So it'll sit there and go, oh, you only have one virtual machine running on this GPU, when in reality you may have 2 or 3 running on it. So it doesn't quite update as fast. I actually had to put a sleep timer in because the code was executing too quickly. So we're getting to the end here. We have a timeline of when you can actually expect to see all this. I want to have the code samples up so that you can at least play with the Python code and everything tomorrow. Again, this is lab use only, but you'll be able to drop this in a Python environment and power it up and run it against your environment. First or second week of September, depending on how my schedule goes when I get back, I should have the basic API available for everybody to use. Again, lab use only. October or November, I should have a beta plugin out for everybody to put into their environment and try out in their home labs or lab spaces and see all the different capabilities that you can actually execute there. March, I should have the security enhancements and a fully functional plugin with all the security stuff that I'm aware of fixed. And then in the future, and this is a request I just got earlier today on my code session, you should actually see a container version. I had somebody request a container version. So that's the timeline of when you can see this. It'll all show up on my website, wondernerd.net, or on my GitHub, github.com/wondernerd. With that, thank you so much for attending. Please take your survey, and I want to open it up for questions. My buddies back there in the sound booth actually hooked me up with some tokens. So if you've got questions, I've got tokens and an opportunity for you to get a shirt. So, any questions? Yes, sir. Right now it is strictly NVIDIA. because NVIDIA is the only one that has a real virtual GPU. So I'll get you hooked up with one. Cool. Any other questions? Yes, sir. So the question was, what are the limitations of the GPUs? So as long as it's a commercial grade GPU for the data center, it'll work just fine. NVIDIA follows very specific formatting rules. And so, like I said, I've been testing this on a P4 and a L4. They both work perfect. And I'll get you hooked up as well afterwards. Any other questions? Awesome. Well, if not, thank you all so much for coming and listening to why I make mistakes and learn from them.